A body is projected at t equal to 0 with a velocity 10 meters per second at an angle of 60 degrees with the horizontal. The radius of curvature of its trajectory at t equal to 1 second is capital R. Neglecting air resistance and taking acceleration due to gravity as 10 meters per second squared, the value of R is 10.3 meters, 2.8 meters, 5.1 meters and 2.5 meters. Okay, so the initial velocity is given, so V is given 10 meters per second, we are given theta which is 60 degrees, okay, and we have to find out the radius of curvature of its trajectory at t equal to 1 second, right? Now how are we going to handle the situation? First of all, we will go to velocity. Okay, what is the formula for velocity? Can anyone recall? It's v cos theta plus v sin theta minus gt. This is j cap, this is I cap. Is that correct? Okay. Yes. Now, velocity at t equal to 1 will be, okay, v is 10 cos 60, so cos 60 is half, so that will be 5 I cap plus v sin theta 10 into root 3 by 2, 5 root 3. Now t is 1, so it will be minus 10 j cap. Okay, 5 I cap plus 5 minus 5 root 3 minus 10 j cap. Okay, now tell me whether 5 root 3 is greater or 10 is greater. Five root 3 is greater than 10. No, it's smaller than 10, right? It's smaller than 10. Okay, so it will be negative. Shouldn't matter much to us, but anyways. Okay, just an estimate of the location of the particle. Okay, it's an estimate to the location of the particle. Okay, the particle's velocity has a negative y component, right? So it has to be somewhere like this. Okay, fine. Now, can we calculate the, okay, what do we want? We want the radius of curvature, right? Fine. What is g bar? G bar is a, or a bar, sorry, a bar. A bar is forever a constant for projectile motion. It is 0 I cap minus 10 j cap. Okay, 0 I cap minus 10 j cap. Now, look here. This is our location of the projectile at the frozen time t equal to 1 second. This is the local horizontal direction. Okay, this is local vertical direction. This is local vertical direction. Okay, and velocity is somewhere here. Where is velocity? Velocity is somewhere here. Okay, velocity is somewhere here like this. This is our velocity vector v bar. Okay, and what we are interested in finding is, we are interested in finding the normal component of acceleration. Do you get it? Which component of acceleration are we interested in finding? We are interested in finding the normal component of acceleration. Normal to what? Normal to velocity or normal to trajectory. Why are we interested in finding the normal component of acceleration? Because we want to determine radius of curvature. A radius of curvature's formula is normal component of acceleration is v squared by radius of curvature. So radius of curvature is v squared by that. Okay, normal component. So this is gn. This is going to be gn. Now the question is how to determine Gn in vector notation, because we basically want the magnitude, right, or An. So any suggestions to determine An? Yes. No, there is tangential acceleration. Otherwise, why would speed increase or decrease? Correct? There, see, this is not uniform speed motion, right? Projectile motion is not uniform speed. Yes. Okay. Now, call this as theta. Call this as theta. Okay, call this as theta. So, do you agree that this angle will also be theta? Angle between any two lines is angle between their perpendiculars. Okay. Can we find that angle theta? Can we find that angle theta, or if not, can we find its cosine? Okay, can we find its cosine? Let's see. I think we can find its cosine because cos theta is x upon r. Okay, we know x coordinate, so we just need to know the speed. What will be speed? Under root pi y squared, so 25. 5 root 3 minus 10 the whole square. Okay, what will be the square of the first? 25 into 3, so that will be 75. 10 squared 100 minus 2ab. 10 into 5 50, 50 into 2 100, 100 root 3. Okay, 100 root 3. So 25 plus 75 is 100, 100 plus 100 is 200. Take 100 common, so it will be 10 into bracket 2 minus root 3. Is that correct? 25, 75, 100, 100 plus 100 is 200. 200 minus 100 root 3, take 100 outside, 200 will become 2. Yes. Okay, so that is the magnitude of the speed. So what is cos theta now? Cos theta is x upon r. So it will be 5 upon 10 into root of 2 minus root 3. So it will be 1 by 2 bracket 2 minus root 3. Is that clear? Yes? Okay. Now recall that radius of curvature is speed squared upon, okay, fine, speed squared upon what? Normal component of acceleration. Okay. Now what is normal component of acceleration according to the figure? It is g cos theta. Right? It is g cos theta. Right? It is g cos theta. Yes, that's g cos theta. So v squared is 10 into 2 minus root 3, and g is 10. And what is cos theta? Cos theta is 1 upon 2 into root of 2 minus root 3. So it will be 1 here, and in the numerator we shall now have 2 into oh wait, this should be 100. V squared is 100 into root sign will go, g is 10, cos theta will be 1 upon 2 into root of 2 minus root 3. So 2 into root of 2 minus root 3. Okay. 10. So it will be 20 into 2 minus root 3 raised to 3 by 20 into bracket 2 minus root 3 bracket closed raised to 1.5. Okay, so the actual is 2.77. We get a better answer or we go closer if we do not approximate the cube directly. Okay, yeah, so I think the better option is 2.8. Fine, so it's not 2.5 but 2.8.